Welcome to an introduction of comprehensive guidelines on determining the safe reuse of treated effluent, proposed and published by the Global WASH Cluster. Let's navigate the essential considerations to determine if conditions are in place to reuse treated effluent safely. Question 1. Are the conditions in place for safe reuse? To answer this, consider the following guiding questions. Is there sufficient space for controlled on-site reuse, such as irrigating low-risk crops with treated effluent? It is recommended by the guidelines that the reuse should occur exclusively on-site at the treatment plant. Are all the necessary information, tools, means, and materials available to handle and monitor the treated effluent throughout its implementation? If the answers are yes, reuse practices must adhere to national legislation or standards. If these aren't available, follow WHO guidelines for the safe utilization of wastewater, excreta, and greywater. The implementing agency must demonstrate the safety of the reuse practice for the community, sanitation workers, and end product users through effluent quality data and safe management plans. If the answer is no, the next question arises. Question 2. Are conditions in place for safe infiltration? Here's what guiding questions to consider. Is the groundwater level at least 1.5 meters deeper than the bottom of the infiltration trench? Please note that the distance increases for fissured rocks and limestone. Is the closest water source more than 30 meters from the infiltration point? Has the soil's infiltration capacity been verified through an infiltration test? If the answer is yes, the environmental and public health impact is minimal, and no liquid effluent monitoring is necessary. Ensuring proper solids and liquid separation before infiltration is crucial for sustainable, long-term operations. If the answer is no, the next query follows. Question 3. Are conditions in place for safe discharge to a surface water body? Here's what's involved. Are all the essential information, tools, means, and materials available to safely monitor the treated effluent throughout its implementation? If the answer is yes, the standards for discharge are based on the trade-off between treatment impact, considering health and environment, and the feasibility of achieving them. Most parameters can be measured using field kits, except for Helminth-Eggs analysis. Research is, however, ongoing to simplify the analysis. These parameters and minimum values, if not otherwise defined by national standards, are pH range of 5 to 9, E. coli levels below 1,000 colony-forming units per 100 milliliter, Helminth-Egg concentration below 1 per liter, total suspended solids below 200 milligrams per liter, chemical oxygen demand below 250 mg per liter. Total nitrogen below 25 mg per liter. In cases where analyzing Helminth concentration isn't feasible, ensuring that the treatment effectively targets Helminth removal is acceptable. Helminths can be removed through sand filtration and high-temperature drying/composting methods. They tend to accumulate significantly in the solid fraction. When the receiving water body's flow significantly exceeds the flow of discharged effluent, less stringent effluent standards can be negotiated and agreed upon with the local government. Navigating these questions and responses ensures careful and responsible management of treated liquid effluent.